Sathyabama Institute of Science and Technology, deemed to be University, Chennai. For admission, contact 99400 and 99401 For further queries, visit www.sathyabama.ac.in.
Hi, good afternoon all. Warm greetings from Sathyabama Institute of Science and Technology, deemed to be University, Chennai. My name is R.M. Joni. Hope everyone is safe and well at home. We are extremely happy about the overwhelming responses. Thank you all for your tremendous support. On behalf of the organizing committee, I take the privilege in welcoming you all to the live webinar on product design and development organized by Sathyabama IEI student branch in association with the Institution of Engineers, India. I also welcome Mr. Sridaran Kuppusamy, who has joined us from United Kingdom to handle this session. We welcome you, sir. It is indeed a unique pleasure and privilege for us to express our sincere gratitude to our founder chancellor, Colonel Dr. J.P.M., for who always showers his divine blessings. We take this opportunity to express our deepest gratitude and earnest thanks to our Chancellor Ma'am, Dr. Maria Johnson, and the President Sir, Dr. Murray Johnson, and who always provide their continuous support and high endeavors in motivating us to organize this online webinars during this COVID-19 crisis situation. Product design is a very broad, coefficient, and effective generation and development of ideas through a process that leads to new products. Product development engineers create and test new product designs and formulate manufacturing specifications. They identify the goals, integrate the market research, and perform design analysis. Product design engineering refers to the process of designing and developing a device, assembly, or system such that it can be produced as an item for sale through some production manufacturing process. It includes design, development, and transitioning to manufacturing of the product. And today we have Mr. Sridaran Kuppusamy, Project Engineer, Acre Solutions Limited from Reading, United Kingdom. We welcome you, sir. Mr. Sridaran Kuppusamy has mechanical design engineering experience for 16 plus years with 7 years in United Kingdom and 3 years in Norway, and also commercial experience working with mechanical design projects in the engineering and manufacturing companies with strong experience in detailed mechanical designing and design calculation analysis using CAD, CAM, and CAE tools. He has also professional experience and exposure in several industries in subsea oil and gas distributions equipment, automotive, and construction technology equipments. We are very happy to have you here, sir, to deliver a talk on product design and development. Over to you, sir.
Hello, good afternoon to all.
Sir, you can share the screen and start.
Yeah. So
Thank
very
you,
good afternoon. Yeah, very good afternoon. Thank you, Johnny.
Yes, sir.
Yeah. Very good afternoon to you all. Be safe and follow the government guidelines for during this corona pandemic. It's everywhere. So first of all, the safe message from my side, and follow the guidelines of the safety. And yeah, my name is Sridaran Kuppusamy. I'm working as a project engineer in Acre Solution, which is a subsea. May not be, most of the people may not be aware about the subsea. So I will give the introduction about that, what is subsea, and then in general we will go about the product, what is product design and development. So say the product design, so it says the design. Design is the creation process. So what's the, let's see, anything start with the concept. So we will do the rough sketch, and then we will create a rough model or a sketch. So and in which include number of major parts, and then we will do the calculation. So basically, if we need to do any calculation, we need a free body diagram where the force or which the degrees of freedom. So that's taken into consideration. And also next, the material selection, what type of material we can choose to the product suitable for the requirement, and then in terms of cost perspective. So, and then finally we will create a drawing. So the drawing is the final product of the design, but before the drawings, the design, the name is start from the concept, rough sketch. So then the CAD comes. CAD is a tool that in olden days they use a rough sketch for designing. Why we require CAD, you can ask. But what the thing of the CAD is, the use of the CAD is we can create the drawing quick, and we can check the weight, or we can physically see the part in the system, and we can check the weight, and we can, if you want to change the material, we can do analysis. So this all the stage, this creation stage comes in the design. Then what's the development? Development is the execution part. So it's the next advancement level. So it's the next stage of the product is development. What we will be doing is there will be a number of operations that follows to get the parts in physically. So before the part get it done physically or delivered to the client, there will be a lot of process. Like the product might be is a machine.
Hello? Hello? Hello?
Sorry.
Hello, sir. Sir, sir, are you able to hear, sir?
Yes, yes.
Yes, sir. So you can
So-
share the screen also, sir, if you want, okay?
So I need to start from the first, or it's already there?
Yeah, we are not able to see your screen, sir.
So only voice is audible. Okay?
Yeah. Give
Okay.
share screen, sir.
Okay. Now it's audible.
Yeah, but screen we are not able
Okay.
to see, sir. Screen, your screen.
Okay.
Yes, sir. Now only we are able to see, sir.
Okay. Previously, but you can hear the voice, right?
Yeah.
That's fine, because
now only we are able to hear.
yeah, it's fine.
Yeah,
It's fine.
you can start from the first, sir, because many people
Okay.
are not able to hear.
Okay.
Yes, sir.
Yeah. Okay. Now, so let me start from the first, isn't it?
Yes, sir. You can start from here.
Okay, it's fine. Okay.
Yeah.
So yeah, I'm Sridaran Kuppusamy, working as a project engineer in Acker Solutions. So my domain is in the subsea domain. Many of them are here may not be aware what is subsea. Maybe I will give you a bit introduction about the subsea, and then we will go into the product design and development. This is a generic product design I am going into, not in the subsea design. That's a separate topic. But I will cover the process, how the design to manufacturing process, how the handling, what are the difficulties to get and to get the final products to deliver to the client. This product life cycle management that we will go through. So this is a product design. Design is a creation stage which include the concept and a rough sketch, and which include drawings. Drawing is the final part, but before creating any drawing, so we will start with the concept, what we require, and then we will go for the rough sketch, and we choose the material, and if it's assembly, we check the number of parts, and if it's a weldment, we will be creating how many number of parts required to weld. If it's a structural weld required, that we need to be analyzed during the stage of the design. So after a design, we will be doing free sketch, and then free body diagram. So from the free body diagram, we analyze the loads on the structures. So then we can do analysis. So why we require CAD? That's a question now. We can do by hand in the olden days. But the CAD is the tool which can create a drawing very fast. So in the olden days, it create, even in your college, you will be using the drafter and the mini drafter and the large A0 sheet to create a drawing. But when you use the AutoCAD or some software, you can see it's easy to, and also you can check the weight, and then you can see the part physically, and you can check the interference. Suppose you want to change the material, and you can check the weight, and you can do the analysis, virtual analysis of the part. So that's the advantage of the part, the design. So design is the olden days. They used to, the traditional method is that they used to do hand sketch and do the hand calculation. So the hand sketch is transferred into the CAD, and the hand calculation is now used into the analysis, computer aided engineering. They use CAE. So yeah, that's a product design, from the concept to the final delivery. The product of the design is the drawing. Drawing is the final part final part of the final product of the design. So then what's the development? Development is the execution stage. So the advancement of the design to the physically the part in hand. So it's like if you want to do the prototype build, before the prototype build, you need to manufacture. If it's is a single piece part, is they will do machining, or the manufacturing process differs. If it is for a large volume, they will go for casting, and based on the product requirement, they will choose the option either the casting, forging, or machining. When it's a very small scale, they will go for a machining type.
Sridaran sir,
Yeah.
sorry to interrupt. Can you little bit come closer to the mic? A little bit, our voice is not audible. Sir, participants are giving comments. Okay. Can you little bit come closer to the mic, sir? Okay.
So how about now?
Yeah, that's fine, sir.
So okay.
Okay, thank you, sir.
Yeah, it's fine. Yeah, so that's the development. So development, in the development stage, we will do manufacture, prototype build, and then functional testing. So if it's a new product, we do qualification. You may ask what's a difference between function test and the qualification. Uh, Normally the qualification will be exceed the whatever we do the normal test, we will be doing more than that, the qualification. Suppose normal, the pressure rating of anything valve is a say 350 bar, 345 bar. So for qualification, we will do 1.5 times as is the standard says. So yeah, we will be referring some of the international codes and standard. Each country follow different codes. For example, American follows, for petroleum industry, they follow API. API is American Petroleum Institute, and also ISO standard is also there. So, and also Norway, they follow NORSOK. In Germany, they follow DN standard. For automobile, they use SAE standard. So there are various standards available. What is the requirements of the standard, you can ask. Standard basically says the design, the major design and or qualification requirement of the product. So if you are selling any product, we can say our product is tested to SAE 1045. Each standard got different numbers. So it's qualified to that number. That's what when they sell in the marketing perspective. So this is used for the when the competitor product, because when they compliance to their product is compliant to ASTM or ISO standard, that will be more valuable than the other one, because the standard requirement will be very stringent, that the product need to be tested. So it's a product design, is a design is the one, is a concept which we deliver the drawing, and the development is the one which the execution, which is a various process that we can go through step by step. Uh, Basically, just as you can see the image in the screen, there's a subsea. I will introduce about what is subsea, and then we will go into the product. Maybe you may not be aware more about the subsea. So so this is the we can say this is a rig. So this is the semi-floating rig, and this is the floating rig. This is the fixed rig. You can see the structure. So basically, you might be aware until the top portion, but there are a lot of engineerings below the sea level that I will tell. There are a lot of engineering required to for this oil to be drilled. Actually, from this is the bed, sea bed. Below that, we need to for extraction of oil. We will be drilling the sea below the sea bed up to reach the oil. We need to so based on the geographical location, it will be a kilometer or 2 to 10 kilometer deep. They will be drilling to get to reach the oil bed. So somewhere they can get gas and somewhere they can get oil. So depend upon the requirement. So this is the basic structure. Basically, this is you can see the bottle and the straw and the tap. The tap is the control. The various that's a combination of the top. This is the top side and this is the tap. The control is the one. This consists of various instrumentation and as well as mechanical parts. So uh, for the it's a hydraulic parts. So uh, and also electrical control parts, which this is the when they say the riser and the umbilical. So the from the top side there will be a lot of cables will be passing through, and this is the tree, and under this the well bore will start. So this is the connection which the nearest well. So it will be interconnected, and it so from there it will be reached to the top level. So just can see this side. Um, yeah. So this is the example for the piece part. So just a machining part. It's a some L bracket with the holes on this. So the example for this manufacturing. It's a quite complicated profile, not in X, Y, Z direction. In the single time, it's a slot profile. Is even in the CNC, it's quite difficult to make. But nowadays, we require why we require CNC is quite accurate. The man make error. That's why we'll go for CNC. Even for the tube bends, you might be seen in your car. There will be a lot of tube bends. So that can be also from 3D model. So they can generate the they generate the tube bends in the CAM machines. And this is for example for the FEA, so say computer-aided engineering analysis. So this is the CAD, which will create drawings and model. This is the CAM, which is used for the manufacturing. This is for the FEA, we do analysis. And this is the concept. Before going for anything, we need to do the free body diagram. What's the load and case study. Before doing analysis, we need to do the forces and pressure or the stress in the component. Everything will be done by free body diagram. So these are in the concept stage, and this is the one is the manufacturing. Yeah, yeah. Let me go for the next slide. So yeah, and one more thing I want to tell is you need to understand the pressure. So whenever somebody say the word pressure, what does that mean? So for example, atmospheric pressure in normal, what we breathe is in the atmosphere. I'm following the British standard. It will be like we use the bar. In American standard, they use PSI. So in each country, they will follow different standard. So this is the overall picture. Next, next I will say what are all the topic we will cover it. So the content, we'll go introduction about myself, And I don't know how many of you are aware about HSE and how far you know, but how it's related to the product that we will see. But most of the product engineer or design engineer need to focus in this rather than designing. Yeah, in the designing is okay, but we need to focus as a first priority, which is the HSE. I want to say, and one of the case study we can see how it is important and what is the product and what are the product types. This is quite in the marketing perspective. And product design definition, and next we'll go for a product design and development process in the manufacturing. And next we can see the product life cycle management is the PLM. So from the idea, from the concept to the delivery of the product, how the cycle it goes until it reach to the customer. And we see the best design process in the industry, what they follow. Some of the terms you may not be aware. And next you will see new and emerging technologies. What's the situation of the current, what's the requirement and the current situation of the manufacturing industry, and their expectation from the engineers that we will see, because it's a volatile market now. So there is a lot of changes happening everywhere, and we need to adapt to the change. That's a market that we will go through in the new emerging technologies. Okay. So yeah, already Johnny told about myself, but just yeah, I will tell you again my experience. I have a 16 years experience in mechanic design and project engineering in various domain. And subsea, oil and gas, I am in 10 years, and then automotive and construction technology equipment. So construction technology equipments, or you know, the one they use for excavator. That's for the building process at all they'll be using. You can see the Ingersoll Rand machines, or some of the excavator in the roadside works, even the bulldozer. That's all comes under the construction technology equipment. And also I work in various manufacturing companies. I worked in Scotland, England, and Norway. And India. India is my first experience country, and I worked there around six years. During my experience, I worked in complete product life cycle of the product, starting from the concept design to the manufacturing. And also now the thing is from the requirement from the client is the cost reduction. So that's a value engineering is in the top priority now. So how the product can be made cheaper in terms of maintaining the quality, and also the fit, form, and function same. That's a requirement from most of the client because of the volatile market. So this is the product which I am working as a subsea. This is the distribution equipment. So basically, sorry, just I want to check. Can you able to hear?
Say, if you're a little bit loud, it will be fine, sir. Little bit louder.
Okay.
Sir. Yes, sir.
Okay. So just check my volume. Just bear with me a second.
Okay.
So how about now?
Yes, sir. Now fine.
Okay. Now it's fine, right? Okay.
Yeah.
Currently I'm working in the products, the hydraulic flying lead. This is the distribution equipment. Subsea technology is the vast field. No one is the expert in the field. There are various work packs. Like the top side in the here is mostly the instrumentation and is mechanical and more combination of mechanicals and instrumentation. The top side. This is the one. There are various forms of layout. Actually, the one which is shown is the drilling stage. The one which in the first stage I showed is the sorry. So this is the production stage of where they will extract oil, whereas this is the one which is the drilling stage. So the layout will be totally different. So this they say the blowout preventer will be there. So because during drilling operations, there will be there will be a burst of the thing, a high pressure of things about to come outside. So there will be a lot of valves inside, different types of valves and shear rams. So to control the pressure, high pressure of the from the well. So yeah, there are different types of layout into the while extracting the oil. The first stage is the drilling. So this is the drilling. So after drilling, the productions, they will completely remove this BOP and then they install tree. The tree, we can say, that's consists of walls and it connected to the well and they can control. What happened is this is the top of the sea surface and this is the sea bed. So the depend upon the location, the depth of the seabed to the top of the rig will be vary. So basically, if you see in the Middle East at all, they don't require this subsea. They can drill with the top level. They can reach the within 500 meter or less than that. They can extract oil, so they don't need this subsea. But in case of Europe, Europe and also in some part of the Africa and in some part of the Australia, they are doing the subsea. Mainly the subsea drilling is happening in the North Sea and also in Canada. And in US, it's in the Houston. So the largest hubs in the subsea are in the Houston and in Malaysia and in Norway and in UK it's in the North Sea in Aberdeen. So they have. So why we require why the oil is this much cost? You can ask, because the in subsea it is quite expensive in terms of the product, because the product what we designed here need to be corrosion resistant and also pressure balanced, because yeah, you need to understand what is pressure in terms of just go outside the topic and you say the pressure in normal outside atmospheric pressure is 1 bar. Say, I follow British standard. That's I say the bar. In US they follow PSI for the pressure rating. But just for example, I'm saying the pressure for comparative yourself. What is the pressure? So normal outside, what we inhale the air is 1 bar. So our human body is pressure balanced. The lungs is also the same, and we in the outside our atmosphere is the same. So what happens if you check in the car tire, the pressure rating you can see it's not the same as the atmospheric pressure, it's pressurized. So it will be approximately 2.4 bar, is twice that, twice or more than twice it's than the atmosphere. Yeah, it's twice more than the atmosphere. And yeah, the pressure is the force exerting on the surface of the tire. So it's a twice. So you can feel how much pressure inside the car tire. That's twice. So what happens is when the subsea, So atmospheric here is the top of the seabed is say 1 bar. So when it reaches the seabed, it is say for example 300 meter. So here at the bottom of the seabed, the pressure will be 300 bar. So for every 10 meter 1 bar will increase. So maximum if you jump into the sea, a person can go only up to 60 meter. So yeah, that's a distance a person can go. Beyond that, his blood vessels will be damaged because of the pressure inside the sea. So think about the equipment here uh, 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 need to be balanced because they are more hydraulic equipment is connected to the bottom of the sea that need to be always pressure balanced. And so the equipment inside normally for operating the wall, why we require here a lot of walls will be there that will be connected through the umbilical. This is umbilical. So uh, so that's complicated things. That's the hydraulic equipment need to be always pressure compensated, pressure balanced. For that they use accumulators and a lot of subsea things happening. So just is the outline uh, uh, of subsea. So the process will be like a drilling. Once the drilling is over, they totally remove this one, and then they use the tree here and then take oil from that. Uh, once the production is over, then they will go for the workover system. What they will do workover is the one they will check inside the well for more deeper, and then they can go deeper inside. For furthermore, they will do drilling or anything, and then they can check for further exploration. So the three types of rigs will be there. Only we can see in the top side, but based on the requirement, it will change. Yes. Okay. Health, safety, and environment. This is the topic I just want to discuss. Why it is important uh, for design. So whenever we create any design, we need to consider the health safety. The product is compliance with health safety and environment. So that will be the good engineering requirement. Otherwise, if something happens, that will be more damage to the people and also the environment, and also the cost wise also is damage. So it's important that the company will follow the safety procedures, standard procedure and guideline. For example, if you are doing any pressure testing in the wall, the area need to be fully covered, and no one should be allowed inside to the pressure testing area. Only authorized person should be allowed. uh, that's a requirement. And also yeah, that's a factor we need to consider. When it's a simple thing, we need to be always in the HSE mindset when we create a product. Might be thinking what's the need of a cooker here in health and safety. Yeah, there is a requirement, uh, but one thing is the need to follow the safety guidelines, HSE, or in terms of designing or any new product. So these are the symbols just for awareness, but the HSE is a different topic. But what I say is wherever you follow the sign, or if there is no sign, please implement the sign. In terms of in the personal, if you don't drive while using a mobile phone, and do follow the speed limit, and also the seat belt is important. uh, there's life-saving rules. In terms of the work, you, you- only you only the authorized person, if it's allowed, then there only those people are need to enter. And so the second one here is for isolation. Isolation is the one, if you are doing any testing, it should be completely locked, and no one should be entered, even if possible remotely. Diver should operate. And the third one here is the suppose if you are doing any welding or a working inside the boiler or something, only authorized person need to enter. Otherwise, it's not allowed. So make a symbol that says the HSE symbol, that others should be aware, and also others should strictly follow to that. And is working with the equipment, and working in the height, follow the rule, the safe guideline. And also lifting the equipment, follow safe sling, and ropes are used for lifting. This is the general guideline, just to follow. Make as an engineer, keep in mindset about the safe health and safety and environment. So why the product engineer? What he need to do in terms of designing the product? Need to consider, okay, when you are sending normally manufacturing industries, they can't manufacture all the parts. So for us, our company is a service based company. We supply to BP, Shell, and Total, or oil equipment. For us there will be sub supplier. So what we will be doing, we will be selecting the people who emit less carbon. That's one perspective, that you choose. You are saving the environment. And also, as an engineer, you select the paint specification that does not harm the environment. So for example, zinc cadmium, the paint is the cadmium is quite harmful to the environment. So check whether alternative xylon coating can be done for your other option. And also you need to manage the cost as well. So we need to balance such a way that it should be the safe, and should be the cost effective, and it should be the safe to the environment. So that's the example, the product engineer. And also the plastic, if you are going for a consideration any plastic product, check whether the plastic is really required. If it's possible, can we go with any other metallic part, because the plastic is a recycling issue. Or if it's not allowable, then we can go with thermoplastic with recycling. And this material yield strength can be increased for the safety purpose. So normal, for example, if you are choosing a stainless steel body of the valve, normal stainless steel yield strength is 220 Newton per millimeter square. But for a safety requirement, you can ask the supplier to supply to 250 Newton per millimeter square. In terms, you are confident that your valve is safe enough for the pressure. And when designing the pad eye, so you can see the pad eye is the lifting. So as an engineer, you need to do the calculation how much the thickness of the pad eye. So these are on the consideration. I am saying how the health and safety is related to the environment. Health and safety is related to the product and product design. So yeah, that's a case study. Might be you all may be aware about this one recent gas leak. Is the happened in Vizag. It's because of the human error, but what and negligence. But the damage is for the people, and also the failure of the HSE is see the health. People suffered, and then safety-wise the valve failed, and then environment-wise the gas damaged. So this is the you can say product and maintenance failure. So that's the one. Finally they come to the engineering. The failure comes, everything they comes to the engineering. So they blame any other department because they will be involving in from the product life cycle. So as an engineer, we need to consider everything. Even for example, say the pressure cooker as an example. So, so what's a pressure cooker is it has a huge engineering, the same as that of the storage tank. The accident happened recently. So like the storage tank, due to increasing temperature, there is a rise in pressure, which caused the valve burst because of the high pressure. So this has happened, and so what is the root cause? There might be many reasons behind the failure, but if there is an pressure measuring device or temperature measuring sensing device that might be monitored and stopped before the event, or any leakage, gas leakage device also could stop. But there is a failure, there's a lesson learned. Or else, see the same thing, this is considered this as a boiler. So in the pressure cooker, there's the relief valve. So what happens is when the pressure goes beyond the spring inside this is the top, the spring will be there, that will retract, and it releases the pressure. Once this relief valve is up to certain limit of pressure, it can, if you go beyond the pressure, it can release it. So the same thing might be happened. What they could have done is they maybe have another isolation valve, where from released pressure might be stopped. Here another one isolation valve that could stop. Maybe that isolation would be high pressure. So that's a thing we need to consider when we design the requirement. So that's what I'm saying. The HSC is quite important in the product design. This is a quite vast topic, but so for example, I can cover a few things. Next slide. So what is a product? So product is a material. So it's a material. It's a material means you don't think about as a stainless steel or carbon steel, or this is the material we call in the manufacturing industry. The material is the one, the item or good. In some industry, the knowledge. In IT industry, for example, they develop the codes and they sell it. So and even for example, you can take the IT products, even the software support. IT support is also a one product. So all the product involved cost. So the material is the one, the physical part, that's the material cost, and the labor, the person who work on the product to final finished part, is the labor cost. So that's the cost is the different from the price. Price is the marketing perspective. In terms of the competitor, they will decide the price, but the cost is the one. When we design a product, we will calculate the price based on total number of parts, and also the material. So during initial design, we will be doing quotation, and we'll asking to different supplier and check for uh, who can offer quality in terms of cheaper and with all fit forms and functions, with a minimum deviation within the available tolerance. So yeah. Products are the two types, market pull products and technology push products. So basically the market pull products are the demand driven, the currently what the market requires. The basic examples is whatever the product you got in the shopping, or the car, furniture, bike, TV. That's also the demand is based on the current market. This is quite a management perspective, but then the product types, we will go through some of the topics. Technology push is the one that comes from the R&D. So there will be no demand at the initial stage. Uh, so what the demand will rise after when they release the product. So for example, the hydrocarbon hydrogen driven, not hydrocarbon, the hydrogen drive vehicle, battery driven vehicle, or today they are doing a lot of research for low carbon emission. So now the market is looking forward for a renewable type energy resource rather than fossil fuel. So that's the push the demand. So either the successful may be in either type. Sometimes technology or market is both driven by the based on the customer requirement. So now the market is pushing towards for the electric drive and hydrogen drive vehicle. So for the low carbon emissions perspective. So this is the overall view about the product and the product types. So product definition, just as a it's a concept idea to transform to reality. That's the product design. It might be from the evolution of a current design, evolution of the steam engine might be evolved from a different type. So this is maybe the original concept, but these are the evolution from the different types. After steam engine, it's come to gasoline, the petrol, a diesel engine, then hybrid. Now they are looking for a hydrogen cell or a battery operated, but there is a quite drawbacks between hydrogen vehicle as well, hydrogen fueled vehicle as well as a battery. Even the battery, we need a lithium again, they need to emit some carbon, but if they use a hydrogen, they need to use a lot of water resources. So each one has a pro and cons. Yes, product design is the process of imaging, sketching the product from the sketch to the reality. You can see this is the sketch of the electric vehicle, and the reality is the one. So the manufacturing involved from the between these two from the concept to the reality. Engineers will be involved, engineering and the manufacturing involved in the process. So only thing is the customer expectation. That's the key point of the product engineer. See, now the people want low cost because of solar power in abundance we got, and also safe to the environment. So if the customer need that one, as a product design engineer, we need to consider that. So these are the evolution of Bugatti is the world fastest car. So more than 1108 bhp power. So they started initially with something, and then now this evolution of current design, the French manufacturer, and also the mobile phone. Initially we started with something, and then now these all are driven by the market and everything. Now see, you can see the app. Everything we require high configuration, then we will go for smartphones. So everything in the market, the product, the engineer need to be focused. So how the engineers will be communicated through the marketing team and the sales team and the tendering team. So what's the requirement? So this is the overall product definition. So this is the product design and development process. So the four stages. One is idea development, and then product screening, and then prototype and function testing, and the final design. So what idea development is the concept stage. So people from the marketing might be getting feedback. The tendering is the one they will get a quote from the client. uh, uh, and engineering is the group of people. There will be engineers, quality engineers, engineering managers, and also product engineers who will work together for the concept. The benchmark is the one they will compare their product with the product which is available, and if any innovation or something they need to change in the product, that's the whole idea will be discussed during the idea development. Is they say the proof of concept. So it's like it's a virtual product they will do in the CAD model, and then they will go for a discussion, and also they will implement the lesson learned. So everything will be in the idea development. In product screening, they will do assessment in terms of whether they can get margin if they design, if they release the product, and whether they can do manufacturing in their facility, or they can outsource the manufacturing. And labor skill, the labor skill include the engineering effort, and then their facility. And then the cost is the important perspective. We can design, but the thing is our design need to be within the limited cost, and that's the way we do benchmarking. The And then the lead time, how about the lead time is the one, if they order the product, and then when it will be delivered. Say if they're asking for any valve, and then the customer client asks what's the lead time, is the one. The delivery date we need to be, say 8 to 12 weeks. So how they will decide the lead time is based on the long lead item. So suppose, for example, for the valve, the body is quite complicated. For machining the valve body, it takes 5 weeks. So on top of that, after the valve machining, they need to go for a inspection, and then QC. If they do for any welding, they need to consider everything, and then they fix the lead time. So uh, that's quite important. Suppose yeah, any product, even the Apple, we can ask what's the lead time. If they say they're going to release in the September, so they need to consider all the parts. The manufacturing should be passed, and then QC passed, and then their functional test to be passed. That's a that's the lead time. And the next one is the prototype build. The prototype is the one is for the R&D, or if it's doing new part design, then you'll go there, build a build. During the build, maybe due to manufacturing, they can't manufacturing with the size which is required. So we need to be stringent in geometric dimensional tolerancing, and tolerancing, where the fit forms and function should be satisfied. And next is the qualification will be for the new product, which follow the international standards and requirement. Whether the wall will be, if you are going for testing the qualification with ISO standard, then it need to pass like a different type of test before the release. Like if it's a valve, they need to go for cycle test. Cycle test is just open and closing the valve. So if it's they need to open 1,000 times or 2,000 times in the qualification, but normal function test they won't do that much. So that's the difference between the qualification and the function test. And then hyperbaric is the one inside, the same as that of the water depth, the testing. They will create a virtual chamber. In that, they will pressurize and do the test. So it will be same as that of the pressure inside the sea depth. Say for example 500 bar, the valve will tested inside the hyperbaric chamber. So these all include the prototype and function testing. The product will be different based on the product requirement. They will do not all the part will require cycle test. So they need to check whether the product require this testing as per the ISO standard, or API standard, or ASME standard. Based on that, they will be doing testing and creating a procedure, standard procedure. And then the final design. So after testing the prototype, so there will be some issues when doing cycle tests. They need to check if it is a valve. There may be damage in the seals, and then they can looked after into the seal. They can go for alternative seal material, or the manufacturing process that they want to check. And also they will check the supplier identified. So when before releasing the product, then the final design, they need to consider all these stages into consideration, and the final output. If it's just example for a mechanical part. So for example, let's say if it is a valve body, it's a single piece part, then it will be assembled with a handle, stem, various parts required to that. So it's a piece part, it's a material, material may be stainless steel. The output will be the drawing, and why the batch number is required. So for all the product require traceability. Why traceability is the one? If a part get failed or something happened, they can trace, because all the parts look similar. So, but however, they will be having the traceability number. They can check with the supplier who supplied, and then track with them if any failure happens. So all the materials should be having the traceability as a batch number, and the material number. So that's in a manufacturing company they used to have. The assembly will be having many items. For example, if it is a cycle, you have a handbrake, chassis, pedal. So that's all compressors. It's a bill of materials. It may be everything will have drawing. So for assembly or weldment, they will be serialized. Why it's serialized is the one. So for example, if you have a lifting, is a pad is welded to any of the parts. uh, so they will perform load test of the pad, whether it can withstand the load, proof load, or they will check for NDT, non-destructive testing is the one. After the pad is welded into the frame, there may be some the inside the weld will not be proper. There might be something, the material bonding of the weld, improper material, that will be identified with different process or there in NDT. They can check visually, or they do DIPAN, or they do penetrant test. So it's the test which without damaging the material. That's the NDT they will be performing. So for that, serial number will be there, because if it's a mass production, they will be having hundreds of welding, but on the serial number that will be identify the exact one. If something is failed, we can, if something happened, say failed in the customer place, so they will be returned, and we will be doing failure mode effective analysis. So this is the overall picture about the product design and development. So next we will be going through the product life cycle. So this is the manufacturing company usually follow when from the concept and to the final delivery. So the idea development. So okay. So this is the customer requirement, and then we will create a concept which we will implement all our ideas, and we will do analysis, or not in terms of analysis, free body diagram, and then number of parts required. Is a concept sketch will be created at this point, and then in this stage we will be creating a manufacturing drawing. So while creating manufacturing drawing, we will be selecting material. We will check whether which material will be suitable for the purpose. For if it's a wall, whether the competitor, we can check it how their performance, how their products in the market, and then we can check the cost in terms of we will send for the quotation. Is there be a big process? Is the pre-production stage? Once we create a drawing and then we'll do FEA. So it's a both way process. While creating a drawing, there may be some failure in the FEA, and then we will change them. For example, some frame or lifting handle. We will be load test, but if the stresses are higher, then we need to change the thickness, or we will be changing the material as well. In terms of, then we need to change the drawing, and then we'll be sending for the quotation again. This is a cycle process: technical drawing, FEA, and what type of coating if required. Then it goes to the procurement. In this stage, we will be sending the quotation and doing a cost analysis. In this stage, it will go to the procurement. Procurement will send to different suppliers, because nowadays, if it's a manufacturing company, they won't be manufacturing all the parts. They will be separate. So, for example, fasteners, they will be our preferred supplier. They will ask for certain requirements of the fasteners, so they need to meet the requirement. So they need to meet as per ASTM standard. They need to deliver the product as per the ASTM standard. The ASTM standard will ask for the material properties, like mechanical properties and impact strength, and another load test. Everything will be asking. They need to compliance to that. So we will be sending, engineers will be creating supplier requirement document. So that material what you are asking, they need to compliance. So anybody can manufacture it, but they need to compliance with the standard. That's important as per the manufacturing perspective. Yeah, the yield strength is quite important. If something they supply below the yield, some supplier can supply material cheaper, but they need to compliance to standard. Otherwise, yeah, there will be failure while we do function testing or in the on place when we deliver to the client. What the procurement will send quotation, or they will produce send the drawings to the different supplier, and they will do manufacturing. The supplier will decide what type of process they will be doing, and based on that they will estimate and give cost to the procurement. The procurement team will manage. They need to reduce the cost. They will be sitting with the engineers. So what the manufacturer is facing, what difficult is the manufacturer facing for the part, they will be deviating the VAVE. So again, the engineer will be involving. They will be asking the supplier can't supply to the ASTM standard or ISO 1801 standard. So based on that, we need to check whether the requirement is critical or not, because we need to consider the cost criticality of the part. If something is non-critical, we can ask them. Is just for the support, not a load bearing. If it is a structural which we do not require anything, there is no load, then we can go for the fastener, which is a standard, which does not which should be standard, but in compliance we can give some deviation. We can accept the deviation from the supplier. So that process will be going in that. And then we will be doing assembly the parts. Suppose, for example, the wall will be it may be assembled in the manufacturing site. Before doing that, this is a PMI, is the positive material identification, is to check the material composition are correct. So some suppliers say they supply this material composition. For example, in the stainless steel, the sulfur content it should be this 0.08 percentage. Then the PMI test will show what the delivered part will be exactly 0.0. There will be range by 0.06 to 0.08, but within the it should be the range. Otherwise, we will reject that part. That's and also the NDT after welding. So it's a non-destructive testing without physically damaging the part. We will test with a liquid dye pen or a radiography, whether the welding the inside there is any porous or holes. If Because if the welding is not proper, if it's a lifting equipment, it will be cause damage, or it will cause a catastrophic cost to the people or to the environment. So that's the process behind that. Next, we'll be going for functional testing. So if it is a valve, they will be doing pressure test. So if it's a valve rated to 345 bar, they will be doing the proof test. So 1.5 times as per the ISO requirement. If the company says they are compliance with that standard, otherwise, if they don't comply, then they will be selling as a normal. But the client will think about this supplier if they are not compliant to ISO standard, and then the quality assurance will check all the documents, the manufacturing records are in place. So all the parts, the manufacturing record, material certificate, everything will be checked by the quality assurance before the client. They are the internal client will check the product is acceptable range as per the customer requirement. And so final delivery is the complete PLM. So this is the PLM is the process which we start from the requirement to the final delivery. For a best design process, these are the key objectives required for manufacturing companies that follow. Maybe the project planning is important because the lead time. If you say you will be delivering in 12 weeks, they need to plan according to the. They will planning according to the delivery date. What are the operations required for? If so, for example, if it is a valve, there will be number of parts. So long lead items plus QC, and they will QC, and then testing. They need to consider functional testing, and then including QC and then QA. Based on that, they will plan the project. And if it's all the parts will not be manufactured, they buy it from outside the vendor. So they look the technology and who can provide, who can satisfy their requirement. These are the design review is quite important for engineer design, product design. So it's a design review is the one where our key expert will be sitting, and it will be presented the engineer who involved in that concept will be presenting the design to the chief engineer. Suppose if it is a valve, it can describe about the pressure and whether the valve will be capable of withstanding the pressure, and then the flow rate is okay, the required flow rate of the valve. Everything will be checked in the design review. And if anything that can be improved in the recently, for example, the seals is the most failure thing in the valve that cause leakages. So that need to be, if anything, need to be reconsidered. If one seal is not suitable, then they can add one more seal. They can add two more seals, and then they can do more cycle test in terms, and also mostly now thing is reusing. It will be more effective. The engineering will be more cost in terms of hours. Yeah, that's the thing. And they need to have the design standard for industrial and follow industrial codes. As I said, ISO, ASME, there are different standard that the product need to comply. Failure mode effective critical analysis is the one key important. Is the one if anything failed, then they will do uh, this will be done during the design stage itself, based on the product criticality and where the product failed. For example, I go for a simple example. If you seat belt in the car, if you don't wear the seat belt, uh, if you are going, if there is any accident, that will cause a huge damage. That's a criticality. So if the seat belt is blocked, or the latch is locked, and then still but you are safe. That we can say the criticality is quite lower than the one which if you don't latch it. So that's the thing, the key things. In the failure mode effective critical analysis, they will rank the product based on the where the failure happens. For example, the valves, the seals are the things, key failure. If it's a release valve, the spring also, if the springs are not supplied with required deflection is not there, then deflection is not there, then that also causes damage. So that need to be considered. That's a FMECA. Continuous improvement is required. How the product can be improved based on the uh, current design, and also visiting the customer place. HSE focus already we discussed, and also the company will be operating with the standard operating procedure. If they are assembling any part, then if it's a valve, what part need to be assembled first. The sequence of operation need to be followed, and then the quality view, they will be checking the drawings supplied by them, or matching with the dimension in the drawing, the physical part, and also checking the supplier quality. If the supplier is asking for more deviation, well, suppose for example, if you send any drawing, if they are not manufactured exactly what we require, that's they will ask for a deviation. So we need to think about the supplier. So we need to change the supplier. That's one key. Now the thing is KBE, it's a knowledge-based engineering. It's another big topic. That's good for best design process. And workshop, actually engineer need to be frequently visiting the workshop, where what's happening about the product test, is everything going fine. Engineer work is not enough within the design and product design and analysis or FEA. The real product is in the need to pass from the workshop. That's important. And yeah, these are the CAD CAM and the CAE, or the PDM tool is used in the manufacturing industries. For saving the document, they use a product data management software. So if they have different products and a different drawing, they will manage with each part number and drawings of the drawing number, and everything will be stored. If you want to retrieve the drawing, you can check with the description or the material number. That's a PDM and a PLM use. New emerging and rapid changes in technology. So now the manufacturing companies are mostly focused in the improving the product in terms of also reducing the cost, and want more efficient and within short lead time. So they are looking into new options. Manufacturing, just this 5D manufacturing. Normal we have in CAM they do 3D manufacturing, but the 5D manufacturing is one which created a human face in the CNC machine. That's a 5 dimension. Just for example, you can see. Yeah. Yeah. Product companies are looking into sorry. Yeah. Yeah, manufacturing companies are looking into new options like 5D manufacturing, digitization, and also thinking about 3D printing. That's also currently in discussion. Yeah, there will be some drawbacks in 3D printing and 5D manufacturing. If you want to manufacturing high volume, it takes some time. Depend upon the project requirement, we need to consider in this product engineer need to uh, think about this and then consider which option we need. Yeah, and also the industries are looking into low carbon and also want to reduce the fossil fuels like coal and oil. They are looking into electrification and carbon capturing system in focus. Uh, so there will be change in the job roles in the new emerging technologies. In future, the traditional skill will be outdated. So we need to be upskilled to the latest technologies like they are going for digitization and also rework, paperless work, and also they're looking into improving the supply chain, same as the manufacturing. They are going to implement something. They are looking into option like how they perform in Amazon or Uber. So they order from somewhere and they can check where which supplier can give cheaper, and then in that perspective, they find the suitable supplier to their requirement. That's also in the process. That's the parts of the digital transformation. And also in the recent automation and robotics in the manufacturing field in place to reduce the human volume. So the human error, with the human, there may be some there will be potential error. That's what they since at most some industries started implementing robot assemblies in BMW, and then the second, the welding in the robot welding, and then the machining the part, so everything in the so automatic. So the thing is, the new emerging technologies are quite volatile. We need to upskill to the latest technologies. Finally, end of the presentation. Any questions? Hello.
Yes, sir. So
Yeah.
let's wait if if anyone is interested in asking question.
Okay.
Okay, sir.
Okay.
Thank you, sir. Thank you for your session. Now I call upon Dr. S. Karthikeyan, FIE, Fellowship Institute of Engineers, Head of the IEI Coordinator, Sathyabama IEI Student Branch, to deliver the vote of thanks.
On behalf of the Sathyabama Institute of Science and Technology, I thank Sridaran Kuppusamy for giving a valuable comments as well as a valuable session here. And we had a wonderful session here with respect to the industrial orientation as well as a real-time experience. You have shared a real-time experience that helps us a lot. Thank you, sir. I also thank all the participants for contributing your valuable time for listening patiently the presentation. Thank you all.
Thank you, sir. Thank you
Thank
so
you.
much.
Thank you.
Thank you, dear participants. Your certificates will be communicated through the WhatsApp group where you have joined. Thank you,
Okay,
sir.
thank you.
Thank you.
Thank you,
Thank you.
madam.
Thank you.